Today we're going to be making a foldable for converting rational numbers. So go ahead and write that at the top of your math notebook page, converting rational numbers. Next, you're going to need 6 note cards. So go ahead and find 6 note cards and then go ahead and fold them in half like this. Okay, so I have 6 note cards here. They're not going to all quite fit on my paper, so when I make my notebook, I'm going to put 4 on one page and then 2 on the other side. So for your first 2 note cards, you're going to use them to convert from percents. So on the outside, you're going to write P, then an arrow, and F. And this will show percents to fractions. And then your next one, just so you can have them facing each other and open up that way, go ahead and make this one be P, and then an arrow, D for decimals. And then decorate the outside. Alright, here's the outside of my first 2 note cards. Now let's just go ahead and focus on converting percents to fractions. Alright, first of all, let's write down the steps in different colors. Step 1 is to write down the percent divided by 100. Then step 2, we'll get a different color, and that is if the number that you are writing, if the percent that you're writing is not a whole number, like it has a decimal or it's less than 1, if it's not a whole number, then you need to multiply or divide by 100 until it is. And when you multiply the top and the bottom. There goes my dryer. And bottom by 10 for every number after the decimal point. And then step 3 will just be to simplify. If you can. Alright, so let's come up with an example here. Alright, let's just use a whole number first. We'll say 11%. So on step 1, that would be 11 over 100. And then step 2, whoops, it is a whole number, 11%. 11 is a whole number, so it's just going to stay 11 over 100. And then on step 3, simplify. The greatest common factor of 11 and 100 is 1, so it already is in simplest form. So that number as a fraction, 11%, is just 11 over 100. Let's try another example that maybe isn't quite so easy. Let's try, I don't know, 15.2%. So first step, write it as a fraction. 15.2 over 100. Now, there's a number after the decimal point here, so you need to multiply each of them by 10. So that would be step 2, 152, and then 100 times 10, just add a 0. And then the last step is just to simplify. 152 divided by 8 is 19. 1000 divided by 8 is 125. And then that is in simplest form. So there's a couple examples of converting percents to fractions. When you're done with that one, you can go ahead and put glue on this side and glue it down into your notebook. Let's go ahead and move on to converting percents to decimals. This one's actually, there's a really easy way to do this that takes even fewer steps. So to convert a percent to a decimal, move the decimal point two places to the left. And then just don't forget to remove the percent sign. Oops. And that's pretty much it. So if I show you that as an example over here, let's say we had 15%. To convert that, I would just move the decimal point over 2, so it would just be 0.15. Or let's look at our examples from the other one. Let's say I had 15.2%, and I move that 2 over to the left. That would be 0.152. Let's use one more example and say that we had 3.7%. If I move that over 2 to the left, I actually have a blank right there, so I'd have to put in a 0. So 3.7% will actually be 0.037 or 37 thousandths. So that is how you convert a percent to a decimal. The reason why that one's so much easier is because percent means per 100, so every time if you just divide it by 100 or move the decimal point 2 places to the left, you'll have the number that you need. Go ahead and take the next note card and then glue the back here, and then you'll have both of them in your math notebook. Okay, the next two that we're going to work on are decimals to percents, and we'll also do decimals to fractions. So decimals to percents and decimals to fractions, and then go ahead and decorate the outsides of those two. To convert a decimal to a percent, it's exactly the opposite of a percent to a decimal. So step 1, and the only step, will just be to move the decimal point 2 places to the right. Whoops, decimal point 2 places to the right. So I guess we could come up with a new number. Let's say you had 35%, or I mean 35. That one doesn't show up very well. 35. And I wanted to convert that whole number. When you don't see the decimal point, it's always on the right, to percent. If I moved it 2 to the right, I have to fill those blanks with zeros. So that would be 3,500. Let's say I had 75 hundredths. I wanted to convert that to a percent and move it over 2 to the right. That would give me 75%. Don't forget to put on the percent sign. And let's do a mixed one. Let's say I had 5.8 as my number, or 5 and 8 tenths. If I converted that to a percent and moved it 2 to the right, I only have one hole to fill, so that would be 580%. So there's 3 examples of how to convert a decimal to a percent. Go ahead and glue that into your notebook. Step 1 for a decimal to a fraction is to write down the decimal divided by 1. Then step 2, you're going to multiply the top and bottom by 10 for every number after the decimal point. And then step 3 will be to simplify or reduce the fraction. Let's use 33 as our first example. So first I'm going to write down, or not 33, actually, 0.33. First I'm going to write down the decimal divided by 1, so that would be 33 divided by 1. And then there are 2 digits after the decimal point, so I'm going to, on step 2, multiply the top and the bottom by 10, and then 10 again, so by 100. So step 2 would be 33 over 100. And then the last step, to simplify, if you can, but on this one, it's already in simplest form. Let's try another one. Let's try 2.8. So this would be 2.8 over 1, and then I'd only have to multiply it by 10 once, so that'd be 28 over 10. And then to simplify, I can actually simplify that because 2 goes into both of those. 14 over 5. Now this ends up being a mixed number, so this would, I can simplify even farther. That's a 2 and 4/5. I'm going to show a different way of doing this instead of using that whole number there that you can do. Either one works. You saw one way, I'm going to show you another way. So you could actually just take the 2 and leave it out of the whole situation. Just leave it as your whole number, 2. And then 8 over 1, 0.8 over 1. I can then multiply this by 10, multiply this by 10. So I'm going to write that as 2 and 8 tenths. And then I'm going to simplify and notice that I'll get the same answer of 2 4/5. Alright, the last one I'm going to show you, I'm going to walk you through a little bit different. There's so many different ways to do this. Let's say I have this number. Tenths, hundredths, thousandths. This is 5 thousandths. If you can read the number, if you are good at reading the numbers, you really can just skip this first step. And on this step right here, write the number as you see it. So 5 thousandths. And then simplify that. 5 divided by 5 is 1. And 1,000 divided by 5 is 200. So that's 1/200. Either way works. If you're not good at looking at the number and reading it like 33 hundredths, 2 8/10ths, 5 thousandths, then just do this step up here of writing the number and then multiplying by whatever you need to get the decimal point at the end of the number rather than the beginning or in the middle. Go ahead and glue the backside and put that in your notebook. This is what you should have so far in your notebook about converting rational numbers. We've got percents to fractions, percents to decimals, and then decimals to percents, decimals to fractions. Alright, next two cards that we are going to convert today. Fractions to decimals and fractions to percents. It's important to keep in mind when I'm talking about fractions and decimals so far, we've only been talking about terminating decimals. We're going to define both of those words in just a second after we get done with these two cards. Okay, the first thing that you need to check to see is if the denominator is divisible by, not divisible, is a factor of 100. If it is, then you can skip this long division that a lot of people hate. So if the bottom number, like for example 3/4, 4 goes into 100 evenly, it goes in 25 times, you can just take the numerator and the denominator times 25 and then move the decimal point over 2 places to the left since it's divided by 100 as your decimal. So if this bottom number goes into 100 evenly, don't forget to do that. If you forget it, it's fine. You can do long division, and I'll show you that with 3/4 right now. I'll just divide numerator by denominator. So people often forget the numerator is the top number. It goes inside the box, divided by 4. Remember, if you don't see the decimal point, it's right after the number, and bring it straight up. 4 cannot go into 3, so I have to add a 0. 4 can go into 37 times. 4 times 7 is 28. Don't forget the subtracting. 30 minus 28 is 2. Bring down another 0. 4 times 5 is 20, and I'm going to keep working it until I get a 0 at the bottom. And remember, this is only examples for terminating decimals. We'll talk about repeating decimals later. Let's do one more example. Let's do 36 1/25 or 36/125. I'm going to skip this first step here because I can't have 125 go into 100. So I'm going to take long division, 36 divided by 125. Put the decimal point and bring it straight up. 125 does go into 362 times. 125 times 2 is 250. I'm going to subtract. When I subtract, that's 11. 110, which is smaller, so I can keep going. I have to bring down another 0. So now I have 1,100 divided by 125, and that goes in 8 times. 125 times 8 is 1,000. When I subtract, that's just 100. Bring down the next 0. 125 into 1,000 goes in 8 times. When I multiply, that's 1,000. Subtract, I finally got a 0. So this answer is 288 thousandths. So there's 2 different types of numbers, and converting them as fractions to terminating decimals. So converting fractions to percents is pretty much the same thing as fractions to decimals, except for adding one more step of multiplying that decimal by 100. So step 1, you still check to see if the bottom number or the denominator is a factor of 100. If so, you can use the same method of multiplying by that number and writing the top number. If not, though, you're going to have to use long division again. And then finally, step 3 is going to be to multiply the number by 100 to convert that decimal to a percent. I'm just going to use the same numbers again. 3/4. Again, I can take 3/4 times 25 over 25. And that's going to give me 75 hundredths, which will let me write that number as 0.75. And then I'm going to do that last step of moving the decimal point 2 places to the right, which will give me 75%. And then again, we'll do 36 over 125. If I divided it out, I already know from the other one what it's going to be, but I'll work it all out again. Alright, so that's 0.288. If I move the decimal point 2 places to the right, it's going to be 28.8%. Okay, so you've heard me say a few terms here now that we're going to define. First of all, a rational number. A rational number, we'll get more into what a rational number is not later on, but if you just remember that a rational number is any number that can be written as a fraction. So let's write that. A number that can be written as a fraction. As long as, like A over B, any number can be A, any number can be B, as long as B is not 0. B cannot equal 0. If the number can be written that way, it's a rational number. All right, next you heard me talk about a terminating decimal. A terminating decimal is just what it sounds like. It's a decimal that ends. So what is a decimal that doesn't end? That goes into our next vocab word. Our next vocab word, and practice, which is something that might be new to you. All of this other stuff you might have learned already, but definitely the new thing is what a repeating decimal is. So if it's not terminating, it's probably repeating, or it just goes on for ever and ever like pi. But a repeating decimal is a decimal expansion that repeats the same number, or it can be actually even a group of numbers. So let's write this like, let's see, a decimal that has a digit or groups of digits that repeat indefinitely. There's a couple examples here of repeating decimals. We have 4.8333, and that goes on forever. That would equal 4.83 repeating. That's one example. The next example would be where it's not just a single digit repeating, but rather a group of digits, 0.181818, and say that went on forever and ever. 0.18 would be the repeating part, so you would write that as 0.18 repeating, the whole repeating sign over the whole number, 18. All right, your first step here is just going to be to represent 0.45 repeating as a variable. You can use any variable, but I'm just using n. So I just said, all right, n equals 0.45 repeating. That's the first. All right, now if you notice, we have an equation here. N equals 0.45 repeating. So step 2 is going to be to multiply both sides of that equation by a certain power of 10. The power of 10 that you choose is however many digits are repeating. There's 2 digits that are repeating in this group here, so I'm going to multiply, in this case, 10 to the power of 2, or 100. So I'm going to multiply n by 100, and I'm going to multiply 0.45 repeating by 100. That's going to give me 100n equals 45.45 repeating. I just took the decimal point here and moved it over 2 places to the right. Whole numbers don't repeat. They can't repeat. So that's why I took the repeating sign off of that. But 45 is still repeating, so I kept it on there. All right, next I'm going to use the subtraction property of equality. And I know this is going to seem a little bit weird, but we're going to subtract n from each side. Remember, n equals 0.45. So on this side, I have an n, so I'm going to subtract n. On this side, I have the number that I am converting, so I'm actually going to subtract what n equals over here, which is 0.45 repeating. Now the reason why I multiplied by n to that certain power was to be able to line up these numbers after the decimal point. If I kept writing them, it'd be 45, 45, and they would always line up and go on forever. So n equals 0.45 repeating, remember. So I'm going to subtract n from both sides, but on this side it's going to be in the form of n, in this side it's going to be in the form of 0.45 repeating. 100n minus n, or one of the n's, is going to leave me with 99 n's. And that's going to equal, because 0.45 repeating minus 0.45 repeating is just going to equal 45. basically what I'm trying to do, this whole reason I did this was to get rid of the repeating stuff. So now I have 99n equals 45. And finally, after this was step 3, which was subtract to eliminate the repeating part. Finally, I can go into step 4, which is solve this equation and work on getting n by itself. So, first thing that I'm going to do is divide each side by 99. That's going to leave me with n equals 45/99. And then if you can, you simplify. In this case I can divide both of them by 9. 45 divided by 9 is 5. 99 divided by 9 is 11. So I'm left with 5 11ths. So 0.45 repeating equals 5 11ths. Let's try one more example to make sure you got it. Let's try 0.5 repeating. We'll start with the first step of writing it as n equals 0.5 repeating. When I multiply both sides by the power of 10 of the number of digits, it'll just be 10. So I'll have 10n equals 5.5 repeating. Then I'm going to subtract n from each side, which will give me 9n equals 5. Then I'm going to divide each side by 9. N equals 5 ninths, and it's in simplest form. So that's pretty much everything you should need to know to do today's assignment.